All right, good morning, afternoon, good evening, wherever in the world you are. Today is Thursday, July 30th, 2026. And from Reno, Nevada, the Peppermill Spa Hotel and Casino, where we have a class with a company called RG Nets. We are having a wireless LAN professionals troubleshooting class. Day one has completed. Day two is about to begin in a couple of hours. It's 6:15, well, 6:16 now in the morning here in beautiful, warm, deserty Nevada. Now we're gonna start with this wireless LAN professionals Wi-Fi design class that comes to you 100% free, 98% in English. Yesterday, talk about the fallacy of channel overlap. That's where we ended, talking about, when these cells overlap, that they're not perfect circles. The session is already uploaded. I had people ask like, hey, I missed it. Where do I see the video? Is there a video? Yes, there is a video. This class is not only being delivered for free, it's also being recorded. So it is in a website called the Wi-Fi-of-things.com. All the sessions are recorded there and they're uploaded. If you want the class in español, in Spanish, there's the clase de diseño Wi-Fi de WLANPros right there. All of the sessions from Tesos and Wi-Fi are uploaded and recorded. And then the ones we started in English some couple months ago, you go to the link that says WLANPros Wi-Fi design, and there they are. If you go to the bottom, that's the very first class we had. And then as we start gaining progress, then the sessions get recorded and uploaded, and they're all there. So if you want to review something, just go back. The title is going to tell you what that video is all about. And there are some notes in there. We've started adding the chat notes here, collapsible, so it doesn't expand too much the page. And if you have people that you're training in your company, go ahead. This is free. They don't have to sign up to anything. Just have them get trained. We sometimes have to train junior guys or guys that come from different departments. They're coming from the server side of things or the switching side of things or telephony or cellular. And now we're going to add them to the Wi-Fi team so that you don't have to pay for Ekahau classes or CWNA classes or Hamina classes. Sometimes it's hard to get the budget. A lot of people are in countries where they don't have access to these resources or this type of training. Here it is in Espanol and in English, free. This is the full-blown class that we've delivered for years to thousands of professionals, now at no cost. Why? Because we want to share knowledge with people and we want to give access to all of those who don't have access to this type of training to be trained. And Mr. Parsons said, knowledge is like manure. If you spread it around, it helps things grow. If you hang on to it, it stinks. So that's what we're doing, just spreading knowledge and trying to bring this training to people all over the world. We've had people from Australia, Nepal, from India, from Canada, from the UK, Sweden, Norway. I mean, you mentioned it. Chile. We have people from Chile today. We have people from all over the place. Thank you very much all for coming. Thank you very much for participating. I know it's free and sometimes it's even hard to get people to show up for these trainings for free. Like, wow. But those who do, you don't have to be here. Many have to be in training because they're required. And that's what I experienced when I was teaching the Ekahau classes. Many people was there because they said like, well, I'm retiring, but my company required me to be here because we need that, certificate. And then, they didn't want to be there. So it's hard when you don't want to be here, but you guys want to be here. Thank you very much. Today, we're going to be covering about the life cycle of a project. Let me make sure that I have, how do you turn on hang on 1 second. Let me stop sharing here for a second and see if I figure out how to enable. I need my eyes. So where are we at? From Russia, we have people too. That's good. Oh, see, start AI. There we go. Okay, well, there you have it. I'm going to have to repeat a couple things here. This is session 361 of Tesos and Wi-Fi. This is part of the Wireless LAN Professional Wi-Fi Design class that we're bringing to you for free. This one covers the life cycle of a project. Let me, from Poland, see, we got people from Poland too. That's great. Let me add my share screen to this. And we're gonna make sure I have my little guy in here. Okay, life cycle of a project on your screen. One blank page. Good. So, where do we start? And this not only applies to a Wi-Fi project, it basically applies to any project. This is just an oversimplification of the life cycle. The first thing is the definition. The project has to be defined. When it comes to Wi-Fi, the clients have it easy. What do they want? Wi-Fi. Where do you want it? Well, everywhere. For which device? For all of the devices. Can you do it? What's the salesperson going to say? Of course, salesperson is going to say yes to everything. And they're going to say like, well, I read also in this book that you can get, 9.6 gigs to, yes, we can do that. And it says that it has M gig and it has, yes, we can do that. And it says that you can do, 4 spatial streams. Yes. The salesperson will tell yes to everything. And then it's for every device that we have in the factory. And then we can get 1 gig everywhere in the wireless. Yes. And then they sign a contract. Usually they define this, at a club, at a meeting, at a dinner, and they come to an agreement. You need Wi-Fi, I'll sell you Wi-Fi and switching and everything. Then once they agree and sign a contract, that contract is given to a person that is going to do the design or a team. And they will just put in a floor plan, an AP model, and now a piece of software spits out a floor plan with now blue dots or orange dots or any dot, any color your company has. And then that design is given to somebody to go and do the deployment, mount the APs, run the cables, do everything, and configure and deploy it. And then somebody else will go and validate, because companies have the pre-sales team, and then they have the design team, and then they hire some contractor to do the deployment, and then somebody else has to go and validate. Usually the person that is going to validate this is the post-sales engineer, and usually they get involved when things don't work. And then they realize that, there are some areas that, there is no Wi-Fi, or it's too slow, or it drops. Then they call you, the post-sales engineer, and then it's going to say, can you just go to that customer because the plumbing was done and they are not paying the other 50% because they're not happy with it. So you got to go find out what the problem is. Then the person goes, you do a survey, and then you say there's actually, in this room here, there's supposed to be an access point, but there's not an access point. So they call the people that did the installation, and then they say, I'm at this job site, and I'm calling about, the conference room. And then they say I knew you were going to call about it. Like, the thing is, when we were going to mount the AP, they were having a meeting over there. And then we couldn't just go in and start running stuff. So we went to the room next door to put the AP right there. But then nobody had the keys to that room, and we ended up putting it 2 rooms down there. And then we checked that we could see the network, and we could see but the design does not match what the actual deployment is, or the deployment doesn't match with the design. And then, you talk to the design people, and then they never went on site because it's another team, because it's another company. And that happens a lot. And as you can see, these 4 stages of the life cycle of a project usually are done by 4 different entities, sometimes, most of the times. And then the other problem is that it's 4 disconnected pieces of information. Somebody defines the project. Sometimes it is the customer says, here's what I want. And then another was like, sure, I'll give you a proposal and I'll tell you, how much the APs are going to cost. And then they hire somebody else to run the cables, and they say, hey, while you're at it, why don't you mount these modem things up in the ceiling, the routers, or Wi-Fi modems, or whatever people call them, because that's the other thing. They're like, I don't know, the cable, yeah, sure, you pay me, I'll mount them. And then they go mount the APs, and sometimes they mount them in the wrong place or mount them in the wrong orientation. They're supposed to be mounted in the ceiling, they mount them on walls, they put them upside down. If they don't have a project manager that is in charge of everything and letting them know how it is, and if you, the Wi-Fi person, you're not part of all of these stages, then most likely you're going to get called later to validate and do a survey, and then start pointing out like, yeah, I don't think this directional antenna intended to cover the seats is going to work good if you have it aiming at the ceiling. That's happened to me in many places, that the APs are mounted upside down, aiming at the ceiling, that the APs are inside metal boxes. So here's the thing. For the life cycle of a project, in this case, a Wi-Fi project, just move this guy around. The ideal is that you, as a Wi-Fi professional, that you are part of all stages of this life cycle. You have to be part of the definition. And then you may say like, oh, no, Ferney, that's not us. That's another team, the salespeople, those are the ones who are always going to parties and taking people to clubs and, closing the deals. They take you to lunch all the time. And then there's this pre-sales engineer, and he's the one who decides, what model and when and all the stuff. And they say, no, you have to be part of this. I, at the school district, had to do the same thing, because the definition, sometimes it's done by the architect, and they give you floor plans, and they say like, no, you don't have to worry about the Wi-Fi. We already put the Wi-Fi modems in there. Wi-Fi modems? What's the Wi-Fi modem? Oh, the router, the white box, that's called an AP. So, okay, yeah, well, we already put the APs there. Where are they? See what that little, the stars, that's what the stars are. The stars are the APs. And then many times I had these architectural designs, and they had one star in a wing of 8 classrooms, like 8 classrooms with one AP in the middle of the hallway. 4 classrooms from this side, 4 classrooms from that side, one AP in the middle. That's a design that the architect did. Like, why? Well, that's what we've always done. That was many years ago, 2 decades ago, they were designing like that. So like, no, that's not how it goes. We have to define the project and also help the customer. The definition of I need Wi-Fi everywhere for every device doesn't really cut it in real life. We have to start asking questions, and we may sound like a 5-year-old. Why? Why do you need Wi-Fi? Well, we have devices. Which devices? How many devices do you have? Oh, we have 600 devices. Okay, what type of devices are they? Are there laptops? Are there tablets? Are there barcode scanners? What type of devices are they? Are they robots that go on the ground and they are carrying merchandise back and forth? Are there trucks in a mine? Are there tablets? Are there wearables? Are there computers in a dentist office that go inside a metal box against the ground? What is it? And then you have to start defining all of this. The definition is not just about Wi-Fi. Wi-Fi is just like one of the items. Like, okay, you need Wi-Fi. Do you have Wi-Fi right now? If you do, what kind of Wi-Fi, what brand, what model, what type of switching do you have? What type of cabling do you have? I had places where they were planning to upgrade the Wi-Fi, and all they had was Cat 5, not even Cat 5e. And that may work for some distances and some lengths and depending the cabling they put. But if it's a 15, 17-year-old cabling, yeah, maybe you're going to have to rerun cables. And the cabling is a big part of it because APs need cables. And people say, no, we don't have budget for the cabling. We can only buy APs. And sometimes I've gotten requests, hey, for now, I need a quote for 30 APs. But for where, why, and why 30? And like, yeah, this is not like end of the year, we have budget, we have to use it or lose it. So we're having problems with the Wi-Fi, and we said, let's just buy, APs. And then they buy 30, and it's like, why 30? Like, because I already have 30, we're having problems with them, so we're going to buy 30 new ones. And then if it doesn't work, they're going to say, yeah, Wi-Fi you sold me is not good. Like, but why did you ask for 30? Well, because we didn't have time to do anything. We thought that buying 30 new APs and replacing just one-to-one the old ones that we had was going to fix it. Evidently it didn't, because if you're trying to replace that one AP in the hallway that covers 8 classrooms, and yeah, back in the day, there was maybe 1-2 devices per classroom. The teacher had a tablet or a computer, and so one AP for 8 classrooms with 2 devices each, that's 16 devices, maybe. That was sufficient. But now what was the problem? They started bringing carts of Chromebooks and put 30 on this classroom and 30 on that classroom and 30 computers on that one. And now, 3 por 8, 24, we have 240, 260 devices connected to the same one AP. That's not going to work. That's going to be a density problem. Now you have to redesign. What did we start doing then when that hit? We started moving APs into the classrooms, putting one AP every other classroom and removing APs from the hallways, because hallways have a lot of problems when it comes to design. Once we get to the design portion with Hamina, with Ekahau, with Tesos, with Wavelify, we're going to see on all of those tools what happens when you place APs in hallways. Then we started redesigning. Well, if you're going to remove one AP and place now 4 APs, you're going to need 4 cables, not 3 more than the one you had. Maybe you need to change that cable too. So you're going to need 4 cables. And now you need 4 switch ports. So you have to consider switching. You have to consider PoE. The definition is not just about Wi-Fi and the access points and the type of access points you're going to be using and the licensing, because, some APs like Ubiquity, you have no licensing. You buy the AP and you don't have to pay for a console. You don't have to pay for a dashboard. You don't have to pay for a license per AP or per controller. No, you just buy the equipment. That's it. You don't have to pay licensing. If you have Cisco, then you're going to have to buy the AP and license for the AP and a license for, DNA or whatever you have in the back end. Other companies, they don't have controllers, or they just have certain licenses. And if you want additional things, you need special licensing for that module, and if you want extra protection, and if you want this, and if you want that. So you have to define all of those things when it comes to Wi-Fi. And the vendor, sometimes they have a vendor chosen. Oh man, we're a Cisco shop, it has to be Cisco. Okay, then you have a list of models, and which type of models are you going to be using, what type of requirements those APs have, what type of PoE they're going to need. Are they going to work with AF, with AT? Because PoE is the other thing. You ask me, we're going to need PoE. Oh, yeah, we got PoE. Which PoE? Is it AF? Is it AT? Is it PT? What type of power over Ethernet do you have? And do you have enough budget in those switches? Because maybe the switches have the right PoE, but you're not just providing PoE to the APs. Sometimes you plan, it's like, I'm going to have 6 APs in this switch. And then when you go and deploy, only 2 or 3 of those APs work, and the other 3 won't come up. And then you go check, there are also phones, there are cameras, there are access control devices that also need PoE, and they suck up the power from the budget that you had, and now you don't have enough power for your access point. So all of those things have to be defined. Who's in charge of that? Who's in charge of the routing, the cabling, the backbone, if you have to create new IDFs? Money is one of those big things that you have to define in the project. What's the budget for this project? Sometimes they say like, hey, Ferney, we need Wi-Fi, and this is how much money we have. And you're like, man, that's going to buy you 2 APs. Oh, no, we need to replace everything. And budget is not very simple in most organizations. Sometimes they have to go through the board, and then it has to go through multiple meetings and reviews, and you have to convince the group that, this is the solution, this is what we have to do. They allocate budget, and once that's allocated, if you come back and say, yeah, we need more money for the cabling, and we need more money for the switching, and we miscalculated the number of APs, it's not going to be 70 APs. The design says that it's going to be 130 APs. Then they say, like, yeah, you're going to have to wait, to the next budget cycle, which is in 3 months, is next year, or we don't have any more money. Sorry, just do what you can with the money. So the definition goes beyond what vendor are you going to use? Is it the same one we have right now? Or are you going to migrate to a different vendor because you're not happy with the one you have right now, or because the company went out of business, or because you want to approach different things that another vendor does better? All of that has to be defined before even a contract gets signed. Then it's going to be cabling. Then it's going to be switching. Then there's going to be money. What's the money that is available for this project? And sometimes they say, yeah, the cabling, that's not us. That's the facilities department. That's a whole different department that handles that part. So we're going to have to let them know what we need and see if they have budget and if they can approve it. So that's another thing that you have to define. Where is the money going to come? Timeline. Who's going to deal with the time? When do you need this by? Sometimes they say, this is for a summer project. Like, it is the summer. Like, yeah, and we just forgot about this part. Now we have to do it. Like, can you do it like within 3 weeks? Sometimes, like, we cannot even get equipment, that fast. And then sometimes it's that you have the equipment, but there's like nobody to get the installation done or finish the project. Sometimes the biggest constraint that you find this project is interior designers, because they will tell you, you cannot mount the APs there or there or there. Like, why? And they will tell you, like, they look ugly. They're just like, it ruins the feng shui or feng shui. What is that called? The feng shui of the energy in the room. Like, oh, because, they don't look good. You're going to tell me where to place the APs? And those are the ones who tell you to put them above the ceiling, to put them behind the cabinets, behind the equipment. Like, why? Because we don't want to see them, blinky lights, and they distract. Then, yeah, you have to have enough beef there to talk and convince them that it's not if it looks pretty or if it looks ugly. You need Wi-Fi to deliver Wi-Fi. We mount the AP. They say, no. They look ugly. And usually they win. The building owners believe more in the interior designer than in the Wi-Fi people. And they say, like, oh, look ugly. That exit sign green, it's like, it looks ugly. Those sprinkler heads from the sprinkler, the fire suppression system, they look ugly, red pokey things coming out of the ceiling. Why don't you put those sprinklers above the ceiling? They look ugly. Look at it. And then they're like, oh, no, but, it's fire code. We don't have the sprinklers and the exit sign there. Then the fire department is not going to approve occupancy of the building. So we have to have them. Because my APs are not to code, you are going to tell me where to mount them? And they usually get away with it. So like, okay, that's when you have to make sure that you cover that in the contract. Look, I will place the access points where you tell me where to mount them. But I cannot guarantee that the service delivered is going to be what you expect. The AP is designed to be mounted in the ceiling like that. And if you're going to tell me to put them upside down inside a metal box above the ceiling, it's not going to work the same. The performance is not going to be the same. If you tell me to mount them on the wall like a clock behind the filing cabinet, behind the bookshelf, yeah, sorry, but it's not going to work as intended. So the definition, as you can see, is not as simple like, you need Wi-Fi, I'll tell you Wi-Fi. No, it goes beyond that. Sometimes we have to design for buildings that don't exist. So we just have a floor plan and we don't know what the construction is. We have to define what type of materials you have there. You have to define the cabling, who's going to run it, the type of construction, if it's one of those listed buildings or historical buildings, that you cannot touch, you cannot drill, you cannot mount, you cannot dismount, you cannot do a lot of things. So all of that has to be part of the definition. In some cases, let me put Martin on mute. It's too loud. Martin, you're too loud, man.
No, I just want to know, do you have more than one slide?
Have
I've seen
fun.
one slide I've seen in the beginning.
All right, here, let me put you on mute. There we go. Thank you. Then, this definition, oh, let me move this window away from the window. There we go. This definition takes time and effort because nobody wants to go to meetings. Sometimes you end up going to these construction meetings, they're boring, and then they most of the times put the Wi-Fi at the end. So they talk about bathrooms and they talk about windows and they talk about AC ducts and lights and things. And then at the very end, and you're like, they're like, kill me now. Like, okay, now let's talk about the network. So try to schedule things and try to be part of these boring meetings and just be part of the whole thing. The definition is complex. The other thing you have to define is clients. I know for the longest time, I know many guys say that this doesn't apply anymore, but one of the big things that you have to define is the client. And people say, like, what do you mean? Like, yeah, for which client are we going to make these designs? They're like, for all of them. And what do you have? And they say, oh, we have tablets and we have this, and we have computers, you have that. And they're like, okay, you are going to have to help find which device is the least capable, the one that maybe is not the strongest, the better device, the least capable, the weakest, the one with least capabilities, but also the most important. And I know I don't remember if it was Sam or someone put a blog or a post about like, yeah, LCMI, that doesn't apply anymore. That doesn't, like, okay. But the reality is we do have to find which device is the primary target of this Wi-Fi. We design Wi-Fi for the clients. Yes, we always worry so much about the type of AP and the best AP and the best controller and the best support and the best, like, okay, that's important that you have, the latest and greatest AP and the best PoE. Yeah, that's critical. But what's more important is what clients are we going to have? Why do we need Wi-Fi in this place? Oh, well, let's say we're a warehouse, okay? And why do we need Wi-Fi in this warehouse? Well, we have barcode scanners that we're going to be doing inventory all over the place. Okay. What type of barcode scanners? Are you buying new barcodes? Oh, no. We had these barcode scanners for, forever. They work great. And we want to stick with those. And yeah, we have like 300 of them. And then you go and if they are 802.11b scanners, yeah, putting XAPs or Wi-Fi 7 APs, not like they're going to make them work better. They're still going to be 802.11b devices or G devices or N devices. Then they're going to work as good as an N device. Yeah, new device and new APs will help you in some ways. But if you have G devices, then they're going to go at the speed of G devices. That's it. And work how G devices work. And so they're like, oh, no. If you want to upgrade this network, you're going to have to upgrade. Oh, yeah, no. We cannot buy because, the software was written for just those devices. And if we buy new devices, they're not going to work with the system. Then we're going to have to buy new software and train. They're like, no, that's not an option. Okay. Then you have to define if that is the device I'm going to design for, then this is how things are going to be configured. Because now you have to segregate things, put things on 2.4 for certain things. And if you're going to have then tablets that do other things in other parts of the factory, and there are newer ones, there are iPads or there are Samsung tablets, then you're going to have to look at the capabilities, how many spatial streams, what technology, what can they do? And then you're going to have to design the network for those devices. And then, yeah, the recommendation, well, like you're going to have to design it for that device, the least capable, most important. So in this place, why are the barcode scanners the most important devices? Because we have 300 of them, Ferney, we just told you. And that's the main reason why we need Wi-Fi. Or else, like, what else do you have? Oh, well, we have 2 computers, there, but that's about it. That in 300. So your network, your Wi-Fi network, brand new IPs, are going to be to support these 20-year-old devices. Then you have to design for that device. But no, not just for the device. How about the computer? Well, the computers will be fine, but we have to pay attention to that device that is the most critical in your warehouse. Then they had other warehouses where they had barcode scanners, but they also had voice speaking devices. So now voice was the most important. Why? Because it needs roaming, because it needs secondary coverage. We cover secondary coverage there. Not 20%, not 30% cell overlap. You need secondary coverage everywhere for devices to be able to roam. So now you're going to have to switch the focus or your definition of your target device. If you're going to have a school, sometimes they say like, 800 devices, and then you design for 800, but where are the 800 devices? Been to schools that huge school, then big open spaces, and then the gym, and then classrooms in here, and the 800 devices are just going to be in this wing. That's the business area. And then you have 2 floors or 3 floors or just business classrooms. And there's like 40 here, 40 there, 40, 40, 40, 40, 40. And then you have lots of devices in a small portion of the building. So you have to define those high density areas as well. Maybe the rest big area has 50 devices, but the 750 devices are going to be all concentrated in this place. If you have auditoriums, if you have places where lots of people are going to be gathering, you're going to have to design different. So the definition, as you can see, it's complex and it takes time. And in some projects, we spend 60, 70% of the time defining what they really need, what they really want, because what people have in mind is not the same as reality. Sometimes they just want to do things that it's not possible, So you, as the Wi-Fi professional, have to be able to help them define what they really need and also make sure that you can deliver it. Because the marketing people, they will oversell it. The salesperson, their job is to sell, and they want big numbers, they want big commissions. So their goal is to sell as many access points as possible and as many licenses and switches and everything. And that's good, that's okay. But then you have to start helping in that definition, because if you end up with way too many APs, then you have to go later and say, like, you're going to have to start turning radios off. The interference is so bad that we cannot even make this work the way you want it. So definition, sometimes means making the salesperson unhappy. Like, you idiot, I just had, sold these 200 APs. Now you come and tell me it's only 100 what we need. You just ruined my commission. And then, sometimes you just have to have that knowledge to being diplomatic, to try to balance things in a way that is going to help everybody. Either we make a commission right now and make a big sale today and spend the next 6 months putting out fires, going back and reconfiguring and disabling and moving and trying to explain why we need to turn this off or move this guy to another place. Then you're going to spend the money you won at the beginning in sending engineers and technicians and people out there later, or in just bad goodwill, because your reputation is going to be ruined. Definition, as you can see, takes time, takes knowledge, and takes talking to different committees and the interior designers and the building constructors and the cabling teams, and talking to the owners and talking to the people who are going to be using the devices, talking to the device manufacturers and bringing devices to the lab and testing sometimes, and going on site and testing. And the definition is complex. Questions or comments up to this point? Let me see your beautiful faces. I only have Gurpreet and Guillermo.
So, Ferney, I think I was from Troy that he was saying that LCMI is an old concept. I post the link of the white paper he had there in the chat.
Who
if
was
anybody
it?
wants to read. Is it from Troy?
Troy. Okay. That's not true anymore.
So I put the PDF there in case anybody wants to read that. I mean, it's it's just a valid point he's trying to make. He's not saying it's wrong. It's just that sometimes if you get stuck with that, then you might end up not defining or designing optimally for something which can handle better Wi-Fi, right? So you slow everybody down. I think that's kind of where he was arguing and kind of putting a point there.
Okay. Yeah,
Made sense.
and it's totally okay.
Yeah.
And that's exactly what we're trying to express here is that, yes, you try to find that device without leaving anybody behind. That's part of the definition, is covering all of those bases. And then based on what the requirements are, define how you're going to approach that. If you're going to have legacy devices, then yeah, make sure that those guys are going to be on their own network and on their own band, not advertise those SSIDs in other radios that they don't need to be. If you have a 2.4 only device, there's no need to advertise that network in all bands in 2, 4, and 5, and 6. If you're going to end up with those type of deployments, you're just segregating in a different way. Hey, Saur, I need to talk to you when we're done with the meeting. If you have some minutes, okay?
Unfortunately I have to jump off at 10 because I have Hamina's architect last day of the class today.
Okay.
With Eddie.
With Eddie. Oh yeah, I love Eddie. Say hi to Eddie. Tell me you were in the class here with me.
Yeah, but I can email you. I'll email you.
Yeah. Probably at night. I'm in Pacific time, so we're several hours away. We'll get on that.
Appreciate it. I appreciate you jumping in this morning.
About the class in New York. So yeah. I'll get in touch with you later.
Sure.
I'll be in class.
Thank you so much.
Anyway. Yeah, at the end of the day we can talk. Thank you, man. All right, so that's it for the definition. Now, let's talk about the design. Once the project is defined, then we have to jump into the design phase. Design, some companies will have, let's say, a vendor, and the vendor has a piece of software that they use to come up with the number of APs and the location of the APs they're going to use. Ubiquiti, for instance, it's called, I don't know, does anybody know what Ubiquiti called their design piece? I don't know, Ubiquiti Design, let's say it's called. And it's a software, you bring in the map, and then, you add APs, and it produces a heat map, and it kind of gives you an idea, those APs, how much they're going to cover of the floor plan. I don't think you draw walls or anything. I don't know if AI kind of detects where the walls go. So it goes through the process of letting the user know how many APs is going to need to produce a green floor plan, those heat maps that we all love. Aruba, any Aruba people here? There was Aruba Air.
That was Airwave, Ferney, and they used to have, Airwave used to have something which was inbuilt. I forgot the term now. But Airwave is out now, right? Airwave, they don't have that anymore. It was retired after it was.
They had it like that, and then also, several companies had their own. And then some people just use that software and then put in the, Extreme Networks have their own. And you'll just put in a floor plan, give it an AP model, and then it will help you design and come out with, a map with a whole bunch of purple dots everywhere. And then that's what the design person would come up with and give that to the cabling people. Well, yes, now we use software like Ekahau. Ekahau was the leader and the only tool we used for many years, and it was great. We had access to all these people, and they were improving it and changing it constantly, and we had it in computers with the software there, and it was great. Things have changed, as you know that. Ekahau and DK, I think Hamina is #1 in design. Don't worry, we're going to cover them all in this class, as we go, and I'm going to get you licenses for Hamina.
Air magnet, Ferney. I'm sorry.
Air magnet, yes. Air magnet, that was before, and that was before Ekahau. And that's how I got into Wi-Fi, was in air magnet training with Mr. Parsons, and we had air magnet, and we did the surveys with their NICs, with the Proxims 8494s, and it was great. But then Ekahau started taking over that, and then Ekahau became the brand that we use and the product that was the best for this design stuff. But then now in the market, Hamina is #1. See, that's what Saur is taking, is the architect training with Hamina. And then we're going to have Hamina training here as well. And then Cedos, that's another company is doing design. They're doing 3D, and Wavelify has done, also great things with the tool. We're going to use all of those tools as we go forward. Hey, come on in if you want. You can sit there. I'll just be in class here. Then they're going to have to we're going to be using all of those tools in here, designing and using the software, all of them, all 4 of them. And design, then whatever tool you use, the way it works is you bring in a floor plan, and then you give it a scale, and then you simulate walls, and then you go and add obstacles, columns, beams, racks, and then you start adding access points and changing settings on it, the height, the tilt, the power, and then it generates a heat map. And then based on that heat map, then you can come up with a design that says, yeah, you're going to need 33 APs for this deployment. And then they may say like, well, 33 APs, that's too much, or yeah, sure, that's good. And part of the problem at the beginning with a lot of these projects is that people say like, oh yeah, no, the software says 33, but put 20. Just put 20 in the proposal. We're going to be the lowest number. Once we get our foot in the door, then we start saying, I need more APs, and then we more. And then companies would just buy into the cheapest one, but then they realize that they had to add more stuff later. And then some companies say like, listen, man, if you tell me it's 20 APs, here, sign this contract saying that 20 APs it is. That's what you're telling me, and that's the budget I am going to get. If you need more APs, you pay for them. And in many cases, they're like, yeah, you told me it was 20 and you need more, you pay for them. So now some of these guys that were aiming low, it's like, yeah, no, it's not going to work because I don't want to be held accountable if there are areas that don't work. So just put in the proposal, it's going to be 40 APs, we're going to have extras. But then now they came too high. See, if you didn't do a proper design, you'll be too high. And then they're going to say like, yeah, that's too expensive. We're not going to go with you. They'll go with the guy that is probably going to put more effort into the design. The design is not just getting a floor plan, adding APs to it, and producing a heat map. You have to have the right tool and the knowledge in order to have a good design. You have to simulate the walls. You have to, design is predictive. Design is you are simulating an environment. You bring in a map, you add the scale, you simulate walls. Are those 3 dB walls or 6 dB walls? Are those 15 dB beams or columns, pillars, or are those 30? I don't know. So you may have to go on site and start measuring stuff. That's one of the things we have to do, because ideally, before you deploy in your design, if it says, let's say it's 33 APs, then if you have access to the building, then maybe before you commit and say, hey, it's going to be 33 APs, like, yeah, I wonder if in the design, this AP in the reception is going to cover the reception, the restaurant, the waiting area, as the design says. What if I can go to the site and validate? Usually, this is what's called an AP on a stick. And then you would go on site, bring one of those APs, the same model you're designing with, and place it at the same height you define with the power you define, and then you start measuring. You bring that AP, place it in the reception, and then one click. We're also going to do surveys here later. And then you say and compare, like, okay, in the design, this AP said it was going to cover the reception, the waiting area, and the restaurant. And then when I did the survey, the heat map shows that this guy only covers the reception area, because there is a wall I didn't know about, and the restaurant is all the way back there, and the waves don't make it quite back there because of the walls or the glass, and it's not going to be enough. So you feed that data, and then you measure walls, and you measure attenuation of obstacles, and then you go on site and look at heights and double check everything. So yeah, they told me the ceilings were 2.5 meters high, but hey, this is the reception area, this is really high, and if we're going to put him in the ceiling, it's going to be 5 meters. Then you adjust the design, And then now the design is going to do the math and tell you, oh man, if these walls are thicker and the glass is thicker and the walls are high, this design is not going to work with 33. You're going to need 44 APs. Then you modify the design, and then now you have a more valid. Of course, I'm just talking about one AP. If you are going to go and do an AP on a stick on all 33 of them, that's going to take time. It's going to cost money. Who's going to pay for it? Sometimes they don't require all 33 to be AP on a stick. Maybe you get a couple of samples in the rooms, because if you put an AP in a room and it covers 2 rooms, then you put it in the next room and it covers 2 rooms. Guess how many rooms it's going to cover in the next location? 2 rooms. So you kind of get samples and say, like, yeah, if one AP covers 2 rooms, then you can just do extrapolation of that. Now, if they require that you AP on a stick every AP and they pay you for it, okay, yeah, I'll go and place it. Some people, some companies, they will just not have one AP. They will have 4, 8 APs in the kit. And if it's a deployment of, I know, 200 APs at a hotel or 600, and then you have 8 AP on a stick, then you're going to have to go play 8 APs at a time, and then you survey a large area, and then now you have data for 8 access points at a time. But 8 AP on a stick is going to need 8 APs, 8 batteries, 8 posts, 8 of everything. So it's a lot of gear. But hey, if they're paying for it, sure. And there are some companies that all they do is AP on a stick. And that's to do what's called a pre-deployment validation. Before you deploy the APs, you go validate, do an AP on a stick, and then in your design, it's more solid. I did that at a factory, and yeah, they were under construction. There were forklifts everywhere. We had to use hard hats and hard toe hard boots, and just be all the protective gear and do AP on a stick, because we needed to make sure that the APs they were going to install in the places that we told them they were going to install were going to work fine. Or else, you may end up in trouble, because if you guesstimate where you're going to need the APs and then they're wrong, once the AP is mounted, man, it's not as easy to move it, because you have to relocate pipes or cables or extend cables, and people don't like it. And it's so much easier to drag an icon on a computer and put it somewhere else and get a different one than to move a physical AP already installed with cables already laid. And all this is much more complicated, much more expensive. And maybe after it's installed, it's not as easy to just go in and start moving things around. It's going to cost money. Somebody's going to pay for it, and the customer is not going to be happy. So if you can do a pre-deployment validation, going on site, and it's not just measuring the heat map and how far the waves go from that AP, it's measuring the attenuation of walls, pillars, obstacles, heights, distances. It's looking at the entire construction site and getting things on the floor map documented. I get floor plans sometimes that I say, yeah, that's going to be a glass window over there. And then I go on site and there was the glass. Like, oh, no, they changed the design. This is going to be brick now. And then you're going to have to modify your design. So being part of this, making site visits and asking questions, talking to the constructor guys and all that before the deployment, that's great. So once the design is modified, and sometimes it's the opposite. You say 33 APs, and then you go on site and then you do surveys, and they say, like, man, this AP that originally I thought it was going to cover the reception and the restaurant and the waiting area also covers the gym and the exit to the parking lot. So it covers more because the walls you had maybe were brick and they happen to be drywall, so the attenuation is less. Maybe it's going to come back and say, yeah, the design is going to be fine with 25 APs. Okay. Then maybe that's not what the salesperson wants, but if that's what is going to work better, then design is design, man. You don't use 1 AP per classroom or a ratio to design. A lot of people say, oh, no, we design here, we just get, we place an AP every 15 meters. I say, what? Say, like, yeah. We just get the floor plan. We have a grid already made, and every 15 meters, where there's an intersection, we place an AP there, every 15 meters in a grid pattern. That's not design. Some people do it like, how many clients are you going to have? 800. Why? And then they look at the spec sheet of the AP. Oh, this AP says they can do 20 devices per radio. This AP has 2 radios, so you can do 80 devices per AP. How many clients? 800. And then they do the math like, yep, you're going to need 40 APs. How do you know? Well, you know, it really is. You get the number of devices divided by the number of clients that an HP can handle, and that's it. That's not design. A lot of people do that. The 1 AP per classroom thing is also another thing that has caused a lot of trouble, because they say, yeah, we place 1 AP per classroom. You know who came up with that? It was guys from Apple and Aerohive. They were designing Wi-Fi for schools. Of course, Apple want to sell devices to schools. Aerohive wanted to sell APs to schools, and they were testing, and they used one of these APs we use with the really bad antennas. Remember the ones that we use that had negative gain? And then they placed this AP in a room, and devices could connect to it. And then the AP was so bad that the clients next door couldn't connect. You know, and the other classroom said, it's not working. So here, put an AP in that classroom. And they put an AP in that classroom, and it worked. So like, oh yeah, let's put 1 AP per classroom. And then salespeople love it, because from schools you're calling, hey, you know, I need a proposal for Wi-Fi. Say, yeah, how many classrooms do you have? 40. Why? I'll give you a proposal for 40 APs. And that became like a thing. And salespeople, it was simple. They didn't have to think. You say, how many classrooms do you have? And then what happened was that when we had projects, the IT directors in some places were recommend like, hey, you know, if you're going to buy Wi-Fi, make sure you get quotes for 1 AP per classroom. And then late, before I left the school district, good morning, they started, there was a letter out there floating around from the director of the ISP that we had at the time. And they said like, yeah, we recommend that if you're going to buy Wi-Fi for your schools, that you buy 1.5 APs per classroom. And then I met a guy, had a class, and I asked him like, hey, Barry, what do you mean? I read this document about 1.5 APs per, what do you mean? Like cut 1 AP in half? What do you mean? He said, no, Ferney. We were recommending 1 AP per classroom. Like, I know, I'm aware. And I was like trying to explain people, that's not how you design Wi-Fi. But then we realized that the cafeteria, the gym, the offices, the kitchen, all of these places that are not a classroom per definition, were being left without access points. So we did some research, and then we realized that if you buy 1.5 APs per classroom, then you're going to have enough APs for everybody. Meaning, if you have 40 classrooms, then you buy 1.5 APs per classroom. You buy 60 APs. You have 1 AP per classroom, 40, and now you have 20 extra APs that you can put in the gyms, in the cafeteria. You know, in his mind, that made sense. You buy enough for everybody, and then you have some extras for all these other areas that are not a class. That's not how you design Wi-Fi. That's why you have software. It will do the math, and you need some knowledge, and we'll get to it. Don't worry, we will get to it. With Ekahau, Tesos, Hamina, and Wavelify. It's totally okay. All right. Once you do the pre-deployment validation visit and get all this data and modify your design, then maybe you're going to have to go and do the deployment. And once the deployment is done and everything is set, you're going to go over and do a post-deployment validation or a post-deployment survey. Meaning, hey, you know, we said 44 APs was it. We came, validated, took samples. Now 44 APs are all up and going. Let's do an entire survey of the entire facility and corroborate if our deployment matches the design and if that's what we want. If we needed 2 signals everywhere for roaming, and with 44 APs, we went and showed that we can have 2 signals everywhere, then life's good. Then your post-deployment validation should be easier if you did a pre-deployment validation. Here's the other problem. Sometimes we are called, if I can move this guy around. Sometimes we are called to a project that we did not define, that we didn't design it, we did not deploy it, we did not survey or validate it. Now they are calling us to just do a post-deployment validation. Maybe because they're unhappy, somebody else did it and it's not working and they don't come, or they come and then live with the same problems. So maybe they hire and say, hey, we're having all kind of problems. We paid all this money and these guys that did it, they're just not showing up. Can you come and do a survey, do a validation basically to remediate problems? This was called a remediation survey. So basically, you enter the life cycle of a project through here, through the bottom. You are not part of the definition or the design or the deployment, and you're just going there to validate and trying to find, I don't know, maybe you do a survey, say, man, you have too many APs, or you don't have enough APs, or you mounted the APs wrong. And you gotta be careful when you do this, because sometimes the guys hire you, say, hey, can you do a survey and you tell us why this is not working? And then you go there like, idiots, who mounted the AP there? And then the guy's gonna be like, that was me. What did I do wrong? And they're like, oh, sorry, I didn't mean to offend you. But we gotta be careful, because we don't know why people deployed it that way. You know what happened to me? In France, Charles de Gaulle Airport, I showed in class to all my students, like, look, they mounted the AP, like that, vertical, when they're designed to be mounted in the ceiling like this. And in another class, I was sitting at Peter Mackenzie class. I get up, I'm Ferney, I'm wireless LAN professionals, and, is what I do. And then this other guy, during the introduction stands up and says, hi, my name is Regis. I live in Paris. And what I do is that, I work at the Charles de Gaulle Airport and I do a Wi-Fi in there. And I'm like, Regis, like, oh man, I showed this in class and I'm just curious, because I said, like, it's not to make fun of whoever mounted that AP there, but just to show my students in class that AP is an omnidirectional AP that is supposed to be mounted in the ceiling, and it's mounted on top of a wall, high up, like that, vertical. Why did you mount it like that? And say, oh, Ferney, we tried. We told the guys, say, look, that AP is not supposed to be mounted like that. That AP is supposed to be mounted like this. And the company that hired them said, look, Regis, that's how we want you to mount them, the APs, okay? If you don't want to mount them like that, fine, we'll hire somebody else to do it. But that's what we're telling you to do. We already have the cables and the brackets up there. Your job is to mount the AP vertical like that and make sure the light is facing out so we can see that it's on or it's not. Got it? It's like, okay. But so that's not how you mount those APs. Sometimes we do things because we're told to and we're held to it. And if we don't have the power or the knowledge or the people to help us, kind of like push that a different direction, then sometimes we have to do things because, they told us to. So be gentle. Don't be judgmental, okay? Be gentle when you're trying to point out these errors or mistakes that somebody else have done. And sometimes it's not a mistake. I have mounted APs on the wall like a clock. Let me show you why. Give me a second. And this is not the type of AP I mounted. It was ruckus APs, okay? AP is designed to be mounted in the ceiling like that. At the gyms, they were 15 meters up in the air, way too high from where we needed down here for the teacher to be doing their scanning, and they had meetings in the area. So I started bringing them down. Remember the rule for the antennas, bring them as close to the clients as possible. Bringing them down with a bracket and mounting them on the wall like that, like a 12 feet high, so kids were not, hitting. Well, they started calling like, hey, Ferney, the AP is hanging from a blue cable, because an access point in a gym is not an access point. It's a target. And sometimes kids, hey, let's try to hit it. Boom, they try to hit it. And even if they're not trying to hit it, it's a gym. They're going to be playing volleyball, basketball, soccer. They're going to be balls going in all directions. And what happened was that this thing with a bracket mounted on the wall would get the balls and boom, they would just yank it. Sometimes they yank it off the wall with the bracket and everything. And they will just be hanging there from the cable. So I started mounting them on the wall like this with one of those plexiglass covers from Home Depot, like for alarm covers and that stuff. Putting them, and now the impact was absorbed when balls hit it by the plexiglass enclosure, and my APs were not being knocked down. And my guys were like, see, you told us not to mount the APs on the wall like a clock. Now you're mounting them on the wall like a clock. Like, I know, but I'd rather have the AP mounted down here like a clock, close to the people, than having it mounted properly in the middle of those metal structures, 15 meters. 45 feet up in the air. It still works. Remember, that's one of the problems the Wi-Fi has. It always works. You put it down here, it covers what I need to cover. And it was fine. They worked fine. And then I put 2 or 3 of those in different parts of the gym. Here in the US, we have these big open spaces. You place them down there, easy to access, easy to upgrade, and it works. Know the rules so you can break them. Sometimes, you just have to do things that ideally are not perfect, but they work better. So let me share my screen again. We're about to be done with this session today. Oh, where did my stuff go? Here we go. My screen on your screen now? Yes,
yes,
no, maybe?
it is.
Okay, thank you. So sometimes we are in charge to go and validate, do a survey on a place that is already deployed. And now is when you start making recommendations. I mean, this is exactly as when they call and say, hey, can you come and do a survey and let us know what's wrong? Then it could be that the antennas are mounted wrong. It could be that the APs have high power or low power, that the channel widths are not configured correctly, that they are physically mounted in the wrong places, that they don't have enough, that they modify the building and knock walls down, or they added wings to a building, and then you have to basically redefine. Just use a different color here. You're going to have to redefine, say, from your validation, from your survey, you're going to come to a definition like, oh, okay, let's see. Why are you having problems? Has it always been like that? When did you start having problems? And this is kind of like when troubleshooting comes into play. You go and try to find what the problem is. If you're troubleshooting a problem, you're trying to find who's having trouble with requirements not being met, because the definition is the gathering of requirements. When you are defining the project, you're gathering requirements: money, time, vendor, POE, cabling, switching, licensing, interior designer requirements, customer requirements, end user requirements, device requirements. Definition of a project is the gathering of requirements. Takes a lot of time. Well, sometimes requirements change. Well, we had just one AP per classroom, and then we had these problems. Now we want to modify this, or we only had one AP in the hallway, and now we have more devices. Then we're going to have to redefine. Things have changed. When did the problem start? Well, when we changed to this new barcode scanner, oh, you changed the client. Okay, so now maybe the requirements are different. We're going to have to redefine what has changed. You need more, you need less. What do you have? And then based on that, maybe you're going to have to redesign. Then we're going to have to run through the software again and simulate it a different way. And maybe you're going to have to modify the deployment, add APs, remove APs, add cables, extend cables, replace things. So you kind of like modify, and that's what a lot of these troubleshooting engagements end up in is, you have to redefine the requirements. What has changed? What's new? Are we adding more devices? Are we adding a different type of device? Maybe it's you're going to have to redesign, use the same floor plans and use the software and Ekahau I know has a great way that you will do a survey, and then with that survey, you'll feed AI and then move APs around, and then you can do the design using that data. Hamina also can do that. You do a survey, and then based on that survey, you learn about the walls and attenuation areas. And then when you place an AP in design, it's going to use that data to select, oh, if I place that AP here without you drawing any walls, it's like, I know in the survey, when I measure here and measure there, I lost 10 dB. So there must be something there. I don't know, a door, a window, or whatever it is. You lose 10 dB in this area. So if you place a simulated AP here, when I go through that area, I'm going to remove 10 dB, and then it's going to do all the heat map for you. That's really cool. So if you are called to a site to do a remediation validation or a survey, then this is when you enter the life cycle, and then maybe you're going to have to modify or introduce new changes to any of these other stages. Design, let's clarify a couple of things here. Design is simulating an environment. You get a floor plan, you simulate walls and doors and windows and attenuation areas, and you simulate APs. This is predictive design. Okay. When you go on site and measure the actual AP sending waves, that's a survey. Okay, this validation, where did it go? There you go. This validation, define, design, deploy, there you go. This validation is also called survey in some cases. Survey is not the same as design, okay? Design means you're simulating an environment, you're doing a predictive design, you're predicting how many APs you're gonna need based on a whole bunch of variables you introduce to a piece of software, whether it's Ekahau, Tesos, Hamina, or Wavelify. And then survey means you go on site and walk, click, measure, calculate stuff on site. That means going on site. That's a survey. Some people confuse passive survey with design and active survey with the actual survey. No, just let's keep this straight. Design is design, okay? Predictive design. That's not a survey, because a lot of people tell me, yeah, I'm not going to do a survey and display. Like, oh, when are you going? Like, no, I'm not going anywhere. I'm just going to, in my house, my computer, bring in a map, give it a scale, and add some APs and see how many we need. Like, oh, that's not survey. They think that's a passive survey. No. That's design, okay? When you're going on site to measure stuff, real waves with equipment, that's what's called a survey. Call it what it is. When you're going to build a house, the topo man is going to come and do a survey of the land. The electricians will do a survey. The plumbers will do a survey. Survey means you go on site and measure. That's validation. You're there validating. Design is design. Survey is survey. All right, my friends. With this, we get to the end of session 361 of Tesos and Wi-Fi. Hey, buddies, how are you doing?
I'm doing fine, and how are you?
Doing great. And we got Audrey, we got, man, all the Russian delegation here. We got Pavel, we got people from all over the place. Thank you very much for coming.
Well, thank you for providing these classes, actually.
Absolutely. And remember, it is being recorded. I hope. Did I hit the record button? I better.
Yeah.
Okay. Being recorded, and we're going to upload it to the Wi-Fi things. So this is the end of session 361 of Tesos and Wi-Fi. This is part of the Wireless LAN Professionals Wi-Fi design class, brought to you 100% free, 98% in English. And remember, free love to everybody and free Wi-Fi training to everyone. Thank you very much. Have a great day. I'll see you next session.
Thanks.
Thanks.
Thanks a lot for you.
Goodbye.
Thanks, Ferney. Bye.